Okay, so I want to look at some applications of right triangles. And so this is the start of 8.1. And, you really should pause the video and solve number one, A, B, C, D. All of that is review material, nothing new, in that particular sense. So why don't you take a minute, pause the video, and solve A, B, C, D. Okay, now that you've solved that and you've checked your answers with mine, hopefully I didn't make any mistakes. Again, this is all based with right triangles, and that's the initial part of this assignment in this section is just solving right triangles. We're going to look at bearings. So if you didn't get a chance to look at that bearing video, just to kind of explain what bearings are, please look through that because that's going to help for the next couple of examples. Okay, so here we have an airplane, and it's taking off from O'Hare on a particular runway, and it says it has a bearing of 20 degrees. And if it just gives you bearing, it doesn't say like a north or a south, and then a bearing, and then an east or a west. So it just says a 20 degree bearing. That means it's from north, and it's moving in a clockwise direction. And that's always initially a little bit tough to remember, or it's easy to forget because we're so used to starting our unit circle, kind of like where due east is. But this is north, and we're going to go in a clockwise direction as opposed to counterclockwise. So again, it's a little bit different from what we're used to if it just gives us as a bearing like this. So a bearing of 20 degrees would mean that the plane itself is taking off in that direction. And it says after a mile, it wants to turn 90 degrees and head towards the northwest. Okay. And so, again, thinking about this plane, like if I were to draw a little arrow here to represent a plane. Here, oh, there it is. So here's my plane, right? So the plane is going. Eventually it wants to turn to the northwest. It's turning 90 degrees and it's heading now in this direction. So I want to make sure that I do put a 90 degree marking right there. Maybe go green. So we know that this angle, so we know that this angle here, for some reason that didn't save. There it is. Maybe it was just too quick. So I know that that's 90 degrees. It's heading towards the northwest. And it's going to actually go 2 miles. If I read further in the problem, it's going to go 2 miles in that direction. So let's go ahead and make that 2 miles. Okay. So I know this was 1 mile. I know that's 90 degrees. That's 2 miles. Okay. So what is the new bearing? So a couple of ways we can solve this. One of them is that we can extend this north till it intersects that point right there. So if I were to extend that north line, just so I can compare it, right? So what I'm looking for when it says bearing, again, it's just going to be bearing with respect to due north. So what I'm looking for is this really large angle right there, because that would be, with respect to due north. But we could fill in some missing pieces here with this triangle. So let's go thin here, and let's pick maybe this gray color here. So if that's 20/90, we know this angle, this angle here is 70. And then just by opposite of vertical angles, this angle here is also 70. So that 70 degrees obviously is really important. I could say I'm 70 degrees to the west of due north. So one way we could represent that is starting due north, 70 degrees to the west. But if it just says what is the new bearing with respect to north, that means I'd want to actually go from north and go all the way around. So if I do really 360 minus 70 degrees, a bearing with respect to north in the clockwise direction is 290 degrees. And I think our textbook uses this format. I sometimes use this format because it's based on our old textbook. Either way, it does not matter. If you give no direction, like a north or a west, that means like 290 means it's automatically with respect to due north. Okay. Now, so then that's that question right there. The second question is, after the plane goes 2 miles, what bearing should the control tower use to locate the aircraft? So now, what I'm thinking about is this plane has already passed the line of north. It's over here somewhere. Let's if I go to blue, maybe even extend it even more. Let's say it's like right there. And so now people at the control tower are trying to spot it. And so let's look at that line of sight. So this line of sight from the control tower to the plane at that instant. So that's what I'm looking for. I'm looking for that line of sight right there. So it's this thin little angle here that I kind of want to focus on. That it's not 20 degrees, because 20 degrees is from north to the right, but it's just this little much right there. If I figure out what that little much is, that would be, where the people at the control tower, here they are, lovely, where they would be able to find the plane as it's flying across, the sky. So I'm going to look at the large triangle here. This large triangle here, here, and here. And I know that there's a right angle. I know there's the side length of 1, and there's a side length of 2. And so what I'm going to do is just use right triangle trig, just like I did in that warm-up above. I'm going to actually find this angle here. I know it's bigger than 20 because it's at least 20. There's the 20 mark. I'm going to find that angle right there. And since I know it's right triangle, its opposite is 2, its adjacent is 1, I could say that the tangent of that angle, theta, is equal to a 2-to-1 ratio. So theta is equal to the inverse tangent of 2. Now I'm introducing the inverse tangent function. So I have to realize that there is more than one angle here, but the principal one that the calculator gives me is 63.435. And I have to realize that, well, if I'm thinking about where is the other tangent positive, the other tangent one is down here in quadrant 3, which doesn't make sense for an angle to have a reference angle in quadrant 3, because that means it's more than 180, and a triangle can only have 180 for all 3 angles, let alone 1. So I know that angle theta is 63.435 degrees. Now, remember that there's an initial angle of 20 degrees inside my triangle. So I'm going to take that 20 degrees away so that I can know what that new bearing would be. So take that 20 degrees away, and we get 43.435 degrees. Now we've got to put that relative to direction. So if I start north and I go 43.435 degrees to the left, that is west. So one way to represent that is north 43.435 degrees west. Another way we could think about that is if we just compare that to due north. So we take that away from 360, 43.435. And another way to represent that is just normal 316.565, no direction other than just we assume it's from due north. Either way would be fine. Okay, so another example in that would be number 2. Same concept, except for I guess I realized instead of O'Hare, now we're at Midway. Okay, so it's taking off at a bearing of 40 degrees. So then again, thinking about there's no direction other than just 40 degrees. So I know it's with respect to north. So here's north. Here's, let's say, 40 degrees. So here's the plane. It's going in that direction. And maybe I'll just use a different color here, like green. So I know that that angle is 40 degrees. Okay. So it goes there for half a mile, and then it wants to head towards the southeast. And so now we're heading down in this direction. Here's the plane down there. So I know that's a right angle. And yay, the permission's been granted. Okay, so we know that there's a half a mile here, and then actually it's 1 mile there. So if you're really good at similar triangles, you're going to see that this is the exact same triangle, just scaled down. So that's 1/2 of a mile, and this right here is 1 mile, and we could complete our triangle right there. Okay, and so that we could solve the Pythagorean theorem if we needed to, but the first thing I want to know is like, what is the new bearing? So the new bearing, here's our plane. Let's get blue. I like that for my plane. So here's my plane. Right here, it wants to know what is the bearing of this plane. In other words, what is it compared to due north? So if I think about that's the trajectory of the plane, I go back and I could draw in like a north, south, east, west compass here just to kind of see what exactly is happening. And so what I'm looking for is this angle right there. That would be the bearing of the plane. So I know it's at least 90 degrees, and it's a little bit past 90 degrees. And so what I might want to use is this 40-degree angle that was given and see what I can start filling in for this triangle. And, there's quite a few triangles here, actually. So I know that this is 40, so that has to be 50. And that's a right angle. So that's 40 degrees. And vertical angles, this is also 40 degrees. And then if this were to extend, and that's a right angle, then this is 50 degrees. And then opposite that, angle here would also be 50 degrees. I need to change colors so I can distinguish that. So we know that this is 50 degrees here in this angle, and be by vertical angles, right? So if this angle is 50, then this angle here is also 50, which means this angle next to it is 40. 90 plus 40 is 130 degrees. Now, how else? Wait, did I do that right? 50, 180 minus 50 is 130 degrees. Now, if I think about my initial bearing of 40 degrees, it's 40 degrees in that direction. And I'm going 90 more degrees in that same kind of clockwise direction. So if I add those two together, that's another way to get my net change or my cumulative change of bearing of 130 degrees. So I guess that's one advantage of doing bearings with due north, is that you could accumulate either with a positive or a negative answer in terms of what degree are you compared to due north. Okay, so that's the bearing of the plane or the aircraft, right? Okay, now where should he look? And so what I'm interested in is this line right, let's go here, this line right here. Like that would be its line of sight from the control tower. And so, I know that, that 50 degrees that I see, I see a 50-degree angle right here. So that's important. But what I'm really interested in is this angle right there, because if I could figure out that angle, I could compare that to like north or south or east or west, and that would be the line of sight. So I'm going to do something very similar. I have a right triangle. I know that the triangle outlined. Oops, there it is. I know that this triangle outlined is a right triangle. I know two of the sides is 1/2 and 1. So I'm actually going to find this whole angle because it's the same angle as the last one, if you can notice, because the tangent of that angle is going to equal opposite over adjacent, 1 over 1/2. In other words, the tangent of that angle is 2, which means that angle is inverse tangent of 2, which we had from our last example. It was like 63.435. Okay, so that would be the full angle. And remember, I have a little bit of a 50-degree angle here. So that little bit of 50, if I take that away, that would give me the missing little purple dot slice there. So that's 13.435 degrees. Okay, so that really doesn't answer the question, but it actually is really important to help us find it. Okay, so I know I'm 13.435 degrees to this, like right below the due east line. So one way I can think about that is, like just starting north. And if I know that I need to go 13.435 degrees below the due east line, the due east line would be a 90-degree angle. So one way to represent this bearing is just to do 90 plus the 13.435 to get 103.435 degrees. That would be just a normal bearing. Now, since I'm sort of like in the southern quadrants, I probably would want to start with south, in terms of measuring this bearing. But remember, if this is 13.435 degrees, then the angle that I'm kind of interested in, if I'm going to compare it to south, is actually this angle, which you can't see because I picked not a very good color. This angle right here would be the angle that's from south. So if I do 90 minus 13.435 degrees, that's 76.565 degrees east. So in other words, if I start south and I go 76.565 degrees to the east, which is this direction, I would get that trajectory as well. Okay, so I don't care how you express your bearings. Like I said, I think our textbook does a lot like that. I've seen a lot of textbooks just do with respect to due north. So as long as you are clear in which method you're using, you'd be fine. Okay, so hopefully that's okay for this first section. It might be worth your while to revisit the bearing, just bearings in general, just to, pun intended, get your bearings on them. And then if you have any questions, certainly feel free to email.